Yeah, there we go. All right. So this is where the star sand is from, right, Hania? All right. I suppose we could change the title to something science-y, but it's brief. So the star sand is from this little tiny guy off of the near Okinawa. I just want to get an idea. Oh wow, it's far away. Dude, I'm surprised this island cluster isn't part of Taiwan. Is this part of Taiwan? I'm curious. Let's see now. Here. So what part of the island is this sand from? Do you know? And let's go to satellite. You can see more. I like the terrain. Lots of beaches. Port. Not seeing like any real. Oh, here maybe. There's a little road to a beach there. Not 100% sure. Still, it's fucking cool. I wonder if the entire island is covered, and we're gonna read about this. Oh, here's a little beach area. Condoy Cape. Maybe it would say that though. I need to fill out a specimen card. Oh wow. Oh wow. Cool. Okay, so you guys see all this? This is super, super shallow. Obviously, you can see how clear it is relative to the surrounding deeper areas. But this means a lot of coral, a lot of shallow marine environments, which yield some of the most interesting sediment depositional environments, in my opinion, because you get so many fossils. Like, well, the star sand. So I'm gonna dump this out over here gently. And I don't have actually my other camera hooked up, so I'm just gonna kind of. I got it out. Just got twisted. Like way south. I don't think. Okay, so I'm not in the right place, Fenmel. All right, so this is the mass culturing of living sands. Protect island coasts against sea level rise. This is interesting. Are they actively adding the critters? Sand production by foraminifera, self-sustaining mechanism in coral reef islands. Feasibility of mass culturing foraminifera, Baculogaspina, Piscina, Spherulata. Oh my god. Spherulata was examined. So they're trying to culture the specific spherulata. I'm just going to call it that. So size structure of the cultured assemblage had similar traits to natural population. Culture foraminifera maybe potential. Protecting coral reefs. How are these guys going to protect them? Coral reef islands have self-sustaining mechanisms that expands and maintains the islands through the deposition of calcium carbonate. And calcium carbonate is calcite or aragonite. That's the chemical formula for both of those minerals. It's a pretty abundant mineral. It's probably the most abundant of all the carbonates. I'm almost 100% sure that's true because the others have some amount of other things in them. Generally, things like other pure carbonates just aren't as common, although they're around, they're just not as common. Aragonite is basically a formless or almost shapeless look to it. It almost has a shapeless habit versus calcite, and there's much more to those two different polymorphs in that other than just shape. Otherwise, it would quite likely have the same chemical formula and the same name. But they are polymorphs, so that they have the same formula. And I'm wondering what they're doing with this mineral by marine organisms. So they're okay, of course. So yeah. And the way in which they get deposited by marine organisms is because a lot of the times their skeletons or shells are made of a lot of calcium. So when they die, a lot of the organic material gets destroyed and consumed by oxygen bacteria, and then the shells get littered all over the ocean floor. And eventually, when they get buried, they actually turn into calcium carbonate or calcite, sometimes as a pore filling cement. So they adhere all the other little shells and pieces of sand together over time, and sometimes as a crystalline structure. Limestone is basically calcite, Fenmill. Limestone is just a rock that has calcite cement or dolomite cement, typically. Could have anchorite and siderite because there's some iron. Limestone only bedrock area. All right, so marine organisms produce calcium carbonate. We already know this. However, the human societies established on such low-lying coral reef islands are vulnerable to rapid sea level rises, which is true because they need to be able to photosynthesize. Enhancing self-sustaining mechanisms. Feasibility of mass culturing large benthic foraminifera. So they're going to try to culture a bunch of these little star sands, which is known as living sand. We developed a rearing system with the key components of an artificial lawn. It's a habit of stirring device to create a vertical water currents. So they did 2 different size groups. They raised basically 2 different size groups of living sand to examine size and growth and reproduction under the culture conditions. Oh, whoa! All batches reproduce asexually. Following generations over 6 months in culture, small-sized group exhibit steady growth, whereas large-sized group underwent a reduction in mean size. Because larger individuals died off. Similar traits of size structure between the culture batches and natural populations indicate that our culturing conditions can successfully reproduce environments similar to the habit of this species. Reproduction, consistent size of growth, and size structure similar to the natural population indicate that examined rearing system is viable for culturing foraminifera at a large scale. Interesting. So basically, there were two different groups of the living sand, right? These tiny critters that they were raising. One of the groups, the smaller of the two, maintained its size. The bigger of the two went down in size because the bigger of those critters in that group died off. And apparently, it's successful in reproduction on a large scale. And I assume that they're... Yeah, they're depositing calcium carbonate as they die. Interesting. Ooh, crystal praise is pretty. 1% of Japan's coral reefs are thriving. The rest is dying. So this is their countermeasure, yeah. I just wanted to understand exactly how they were doing it. Basically, they're filling up the beaches with this calcium-rich critter. And as they die, it allows for calcium carbonate to precipitate, which bonds with the CO2 in the atmosphere. The calcium does. More like an energy worker. That's very cool. Less earth science. Oh, okay, got you. Yeah, so I just do science here. To each their own, and I don't mind if people do the metaphysical stuff. I just don't really talk about it or know much about it. I don't study it. It's not my thing. But I don't care if people do it. We can all appreciate the things. I do get cheeky sometimes when it's over the top to the point where it's just like not logical anymore, and I'm sure many of you can agree with this. And I'll giggle at that, but you know, there are a lot of logical individuals that I know that actually use minerals and things in metaphysical ways that I don't personally, but you know, teach their own. That doesn't harm anyone, and they actually read interesting articles and things about it that is intriguing. It's just not my thing. It is awesome as it stands. Exactly, Rev. Put some of this. Let's see. How do I want to do this? I know. I'm going to pour this into a little box because I don't want these to go everywhere. Oh, this is so cool. Let me turn on my other cameras. This is so fucking cool. Focused in because of last night. Yeah, buddy. Sweet. Good. So this is the star sand. Fairly up close. I'd say most of these little pieces are about 2 millimeters in size, which is very large in terms of sand grain size. But this is all the living sand off of the beach that we were just talking about in Japan. There we go. Fucking Ian got it. This is the microscope camera. In fact, why don't we do this? Why don't we, like... I don't want it to be giant. I wish that the borders... Let's put this in the corner so you guys can see what I'm looking at. Yeah? That'll be cool. We'll do that. So yeah, this is the microscope camera, and this is the regular camera. All right? Yeah, yeah. A little better? Can you guys see that better? See all the little sand particles in there? Oh yeah, geology involves so many other sciences. You end up learning quite a bit. All right, so here's the microscope camera. Here's my skin. If you want to look at it. That's my palm. Whoa, magic. All right, let's look at these little sand guys. I'm trying to get a spot that's... I don't want to ruin any of these guys. Whoa! Hania! They look like cereals. I just want to pick it up and play with it. It's so adorable. There's tiny star frames. Oh, this one's cool. Hold on. I had to get this one. It's so big. Look at it. He's like a little cereal donut guy. He's a little sand grain. Ah! Look at it. It's so cute. This is adorable. Oh, there's this guy too. There's a bigger shell in here. There's obviously something else that washed up. Whoa, you can see tiny little things all over a shell. Here's another one. A different guy. What? Are those tiny gastropods on it? Such as part of the way the shell forms. I don't know that that's the case. That's so strange. I can't believe these are all little shells. Oh my god, they're so fucking adorable. I need to get some tweezers in there or something so I can like flip them over because it looks like one side is filled with little pores and the other is not. Oh my god, look at that cereal for your health. It's not cereal, guys, okay? It's actually tiny sand. Star sand, they call it. From a coast off of Japan. Catters. Not cats from catters. Thank you very much for the 500 biddies. Oh my god, that's adorable. Jesus, just like these. They're like little donuts, little cereals. Let's see what else we can see. There's some other tiny shells in here. Oh my god. Oh my god, that's so fucking cool, dude. Look at that. Oh. This one over here, too. Come here. Come here, dude. Come here, little guy. Come here, little guy. You're a little dude. Hey! You do the things! More star sand! Come here, actually. We're just gonna do this. Let's look at these even bigger. Because that's fun. Wonder if we could measure the field of view. We should. So fucking cool. Get an idea about... I mean, it's not like It's not like I can't measure these things with my naked eye and see, but some of these are just so tiny. Look at that guy. He's so little. You could see him on the thing. Barely. You barely see that he's got little legs. They're like they look like little round spiky balls. Like they would probably hurt if you maybe not. They're pretty tiny. But there are also little tiny snail shells in here too. It's pretty funny. Oh, here's that one with the weird looking gastropods on it. You can actually see them. Here, I'll show you. Actually, I shouldn't put that underneath that. Okay, so this guy here has some really weird growths or some shit on his shell, and I don't know the fuck that is, but it's cool. Can barnacles grow on tiny shells? I don't know much about barnacles. Whoa, that's my mouse pad? Gross. God, these are cool, though. They literally... They're just... They're so... Oh, this one. Hold on, hold on. I wonder if I can see the tiny pores. Probably not. Well, this side looks more smooth than this side. I bet the pores are on this side. Let's find out. I don't know what those little pores are. Barnacle. I was wondering if it was a baby barnacle. Picture. All right, I'm gonna take pictures with my phone later, because you can hook this up to your phone, and it'll allow you to take pictures. Look at that though. It's so incredible, honey. This is quite the gift that you brought me. Do you have any idea what this means? Oh wow. This is really, really cool. Oh, one thing I want to do is I want to see if we can kind of determine the field of view. Probably not. It's not gonna get, it doesn't matter. It's not gonna work. I'm not gonna be able to do it with this thing. I wish that I could see. I wonder if there's somewhere with measurements for the field of view somewhere, to be honest. I'm gonna put this back. But yeah, I guess they're trying to see if this is a reasonable way to mitigate some greenhouse gas effects. And as these critters die, their shells are made of calcium, and ideally they bond with the CO2 in the atmosphere, creating calcite. So it's a way in which geologists have determined, as well as some other scientists, I'm sure, have maybe determined to make extra carbonates, the minerals, and also collecting some of that CO2 from the atmosphere. It's intriguing. It's really interesting. I'm curious what the balance is of it. Like, if we overdo it, is there a possibility of that? I'm curious. Like, I know it's not our problem right now, but I'm just like, this is such an interesting prospect to me. And I wonder if they've implemented it anywhere else and how long ago this was done. I'm super curious. So the island that we were on isn't the right island that it was on, correct? The one that I had found? It was off of the coast of Japan, right? Closer to the main island. Let's look up star sand. Star Sand Beach. Oh, here we go. Yeah, it isn't in the right place. You were right. You were absolutely right. No, no, no. We were on the right island. We were on the right island. It's okay. So this is where the area... Okay, no, this was a different island. This is a completely different island. But it's close to the one we were looking at. Maybe we were looking at this one. I don't know. I don't know. But the star sand that we were just looking at comes from this area here. This is cool. I don't want to look at the buildings. I want to look at the beach. Go to the beach. No! I can't do it. That would have been cool, though. Wow. So now I want to look up the star sand. It is a gorgeous specimen. I love that sandstone. It was a gift. It's like the camera doesn't want to behave anymore for the star sand, but I still want to know more about it. So this is what we were just looking at, and I just want to know a little bit more about it. So they're unicellular. Oh, they're protists. I don't know why they added that. It's kind of weird. 10,000 species? Oh, I was wondering about that because some of them looked so different. Some of them were five-pointed, some of them weren't. And typically, that's actually kind of important, especially with index fossils. Typically, five-pointed critters in the sea are echinoderms. So I'm wondering if they are all. This is getting outside of my realm of expertise a bit, but it's nonetheless very exciting. Oh yeah, this geode's pretty fantastic. So this is the geode that he was talking about. They are quite mesmerizing when they're big, and I mean you can even see some citrine bands in there. Some irradiation has happened in this. That's pretty cool. I like when you can see the yellow citrine and the purple amethyst. Oh my god, that deep purple is so fucking phenomenal. I love it. Those are so expensive. This is the new Google Earth? Why is it different than the one that I have? Oh. Hey, this is cool. This is cool. How is this different? Is this new? The geode big. Let's find Star Sand Beach. Yeah. I could just do this for hours, honestly. Just look at Google Earth for fucking hours describing geology. I want to see the stars on the sand. This is terrible resolution faking. I can't see the individual star foraminifera on the sand. I can't see it. Disappoint. Drag a line? How do I do this? How do I do this? Voyager. Whoa! I didn't do the thing you wanted me to do. You don't like the new Google Earth? Why? Whoa, why is everybody so bad? New Google Earth not equipped with a scanning electron microscope view. Every particle on Earth's surface basically worthless. Yes! Paths don't count. Oh, there's a path on the beach? Okay, one sec. I have to go back, okay? Cause I'm dumb sometimes, okay? We're gonna do this. Oops. Maybe not. Okay. No, I believe you. We're gonna see it. Drag the little guy from the lower right and put him. Oh, 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 oh. Apparently, mind just blown, and everybody in the science realm was just like, "Wow, how did Sage learn to use a scanning electron microscope but can't figure out the new Google Earth?" Whoa! I can't see the star sand. It just looks like regular shitty sand. Fuck yeah! So this is where the star sand is from. I love it. You can see their shadow. That's so cool. Dude, look at how shallow those platforms are. Those wave cut platforms. That's actually really unique and cool. Not unique, but very interesting. Apparently, in this area, yeah, there's definitely a shadow of a dude. Look at these wave cut platforms. Holy shit. The geology is gorgeous here. Let's go into the platform a bit. I can't believe they've, like... What the fuck, dude? Look at... They went onto the wave cut platform. I'm actually blown away right now. Jesus, it's just so fucking cool. Yeah, this is my backyard. I'm just kidding. Earth Explorer, WW site? No. What? Are you trying to get me to do GIS again, Drop Bear? Do you keep dropping subtle hints for me to teach you guys GIS? Ah! Someday I will! I'll tell you what. Set up a donation goal of $12 million. $12 billion. And then I'll do education about GIS. It's just been a long time, man. Oh. How far does it go into the water? This guy even get into the water? This dude on foot is like... Not quite in the water. He's almost there. He like stopped right at the water. Okay. Well, I'm trying to figure out because sea level's rising. So I assume that this is actually recent deposits and erosion of a lot of the sand that's out there. So I'm guessing as sea level rises, it's going to erode some of that superficial sand, right, down into the shoreline. But honestly, it looks a lot more like it's not rising here. It's just strange, but I know that's not true. Looks like it's yeah, it's just coming up into the beach and eroding things. And eventually it'll deposit more sand. It just looks so strange. I want to look up the geology of this area now. I know it's just filled with, there's coral out there too. GIS, GeoGuessr. No, GIS is a program used by geologists and other professionals that need to model three-dimensionally into the earth and various things. A lot of oil companies use it. A lot of mappers use it too, geology mapping. Oh, yeah. We can look at the other sand too. Yeah, it's just the tide. This is so fucking cool, man. So you can actually go to Star Sand Beach. And I wonder if they're actively dumping star sand there regularly. When was this produced or published, rather? So this is the beach. This is the sand from that beach. Crusted with time. It's 10,000 species, so yeah, ArcGIS is mega expensive and fails constantly. I wonder, do you in QGIS have you used QGIS and have you noticed if whether or not when you move any of the documents it freaks out like ArcGIS does? Yeah, keep that shit in Oz. It's like, wait, that's not the right thing. Okay. What's the next location? The next area is what was the area called that we're gonna look at? Oh, sure. Iwo Rock Sand. Battle of Iwo Jima. Facts you should know. The Black Sand of Iwo Jima. American Veterans Center. Let's just look at Wikipedia. It's a bunch of history stuff. Black sand is sand that in black in color, one type of heavy magnetic. I should use my magnet. Okay. Heavy, glossy, partly magnetic mixture of usually fine sands found as a part of placer deposit. So, a river deposit. Sedimentary deposit. Yeah, it's alluvial. Yeah, it's just okay. Placer deposit means it's a just sedimentary crap. Okay, people often use placer deposits to mine from. Placer mining is some form of mining that they use for example, in California during the gold rush. Placer mining in California does not happen anymore because it's all been picked up. It might have some magnetic stuff in it, Pikachu. I want to know about no. Specifically Iwo Jima. It just keeps. Oh my gosh. Well, you can buy yours for $24. Does it say anything about it? It's volcanic sand. That makes sense because I saw some glassy pieces. Oh my fucking god. Oh my god. Like, this is very interesting. Oh my gosh. Ah! Let's just look at it. It's volcanic. It's volcanic. I hope so, Pikachu. It's really weird. It's probably because nobody's allowed there. So, from what I understand, there's only 15 soldiers allowed on this entire island? Right? Is that right? Once a year, yeah. So, the island of Iwo Jima. Let's look at this. No. Can I just do this? Yeah. Is allowed only 15 people a year, and it has black sand. Actually, why am I not using this? Come on. All right. Whoa! Whoa! Let's go to space. I wonder. It's interesting because I wonder if you can walk anywhere in here. Probably not. I'm guessing no. Damn, even the shores actually look pretty dark. They do look really dark. Like, considering, like, most beaches are look like a tan or a white from Google Earth. It'd be pretty cool, though, if we can get this guy to... Nope, he's not going to go anywhere on there. There's no fucking way. There's no fucking way. What? What's this? It's loading. Let me do this off of stream. Oh, nice. Thank you. Oh. Now that I've changed it, it should have photos. Thank you very much, Faking. I'm not on a watch list. They're just gonna... Yeah, right. They're gonna be like, oh, what the fuck is this crazy geologist doing? Oh, she's looking at sand on a beach. She's looking at sand on a beach. What? Oh, wow. Oh, wow. It is just a lot of rubble. Look at that. All right. Now we've got a decent picture of the sand we're going to be looking at. This is in... All right. Box number 2. Let's do it. Ooh. And you were given this, honey? Tell us the story of how you acquired this. That is the sand right here. From Iwo I have sand from Iwo in this box. Right here. This is something else, honey. You've really outdone yourself. You've truly outdone yourself. I hope you know that. Jesus Christ. This is something else, man. It's so cool, like. Oh, yeah. But every sand is eroded some kind of rock, Jen. So, what you get on a beach is the result of the erosion from what we call your source rock. So your source rock is basically whatever is being eroded and weathered, and that material is then being carried and transported to what we call the sink. So we have your source to your sink. So usually that means your mountains to the beach. If you look at an area like west coast of South America, the west coast of North America, you see a big mountain chain, right? You get, in fact, in California, you have a coastal range, and all of that sediment from that erosion, weathering, transportation process ends up on the beach there, and then the other half of it ends up in the valley, on the other side of the mountains, right? Conversely, in the valley of California, you get erosion and weathering that deposits all that sediment into that valley from both the Sierras and from the coastal ranges there. So you get two different source rocks. So when you're doing different kind of geologic work with whatever sediment out there, you actually have to kind of figure out where the hell it came from because you have two different ranges. So it's interesting to do that. And I try to figure it out. I actually had to deal with that. It's really interesting stuff. Yeah, exactly. And then that's another thing is, for example, the Sierras are, well, now mostly granitic, but there's still a lot of volcanic stuff out, especially on the eastern side. It's a lot better preserved out in the desert. But there's a lot of granitic and highly felsic stuff being eroded and weathered on the west coast in California. Whereas in Oregon right now, there's tons of, Northern California and Oregon, there's tons of basalt flows, lots of big basalt flows that eventually will erode and can produce sand that looks like this. So it just depends on the source rock. Basalt is a dark color like this. Hawaii even has beaches with black sand on them because it's eroding and weathering basalt. And I'll even show you what basalt looks like. And basalt is by far probably the most common rock in Hawaii. A basalt, then maybe followed by obsidian. But this is, you can get vesicular basalt. You can get non-vesicular basalt. So this is vesicles. This means bubbles. Vesicular, meaning bubbles. Vesicular basalt is a bubbly basalt. It's pretty easy. So this is, I mean, obviously, you're going to get dark sand if the rock is dark, right? Yes, testicular basalt. For your health. Go get your fucking balls checked. This is regular, non-vesicular basalt. But both varieties are very, very fine-grained. You generally can't see any crystals in them. Sometimes in vesicular basalt, though, you get olivine crystals. Olivine basalt looks pretty cool. No, this is like, these are xenoliths from the mantle being pulled up with basalt. That's not. So sometimes you get little individual crystals in basalt like that. Anyway, those little tiny green dots are pieces of olivine. Porphyries. Porphyritic. Yes. Hold on. Metamorphic version of porphyry. What's the metamorphic version of porphyry? Fuck. Any geologists here tonight? There's usually like 12 of you. This is really going to bother me. Whatever. I can't remember. Okay, so porphyry is what these little inclusions are. So if you've got a ground mass, it's all relatively the same size. But then you've got these bigger grains in there, kind of intermittently throughout, then this would be a porphyry, right? It's two different grain sizes. And these would be the porphyries, the bigger grains. And I can't remember what it's called in metamorphics when you get bigger grains that form. Yeah, you shut up. Working and lurking. That's what I always do, man. Welcome. Lurk away, my friend. I'll try not to bother you. Porphyroblasts. Maybe you're right. I think you're right. I think you're right, Ike. Why is this bothering me so much? Getting all my terms confused. I don't think so. I think that's actually a... Yeah, it is. You're right. Porphyroblast versus porphyry. You're right. But they're very, very similar terms. Anyway, I just needed to know that. Thank you. It was going to make me feel crappy. I needed to know. Here's some more vesicular basalt with olivine in it. So you've even got vesicles without olivine and then vesicles with olivine, which is pretty neat. So back to this basaltic beach. So this has just been eroded because this island apparently is a volcanic island. I don't know much on the volcanics of this area, but it is an active, it's on an active subduction zone, this area here. Let me see if I can show it to you. Here's the big fucking trench all the way up Japan. All the way up, all the way up, all the way up. It's pretty extensive, right? In fact, you can see it just keeps going. And oh wow, what do you know? The Ring of fucking Fire! Because of subduction, we get earthquakes and volcanoes. Yay! All right, so you can see all of this subduction here. Jesus Christ, this is actually very, very, very nice look, to be honest. But this is why it's volcanic. You get subduction of an oceanic plate underneath this other plate, which is a continental. And it, well, causes a lot of things to happen underneath the crust in the lithosphere that results in magmatism, volcanism, which is somewhat redundant to magnetism, and earthquakes. What got me interested in studying geology? I got to do all the sciences. I got to be outside. I got to learn chemistry and physics and all the other things that I still wanted to be a part of, while also learning a completely new topic. And it wasn't offered in K through 12 for me, so it was really, really rather interesting and new. And it was just a perfect combination of the things that I loved, to be honest. And I got along with a lot of the other geo majors, especially my master's. It was kind of nice, actually. Whereas my other bachelors, I don't think I really actually made any friends. I didn't really talk to anybody in the religious studies one. I just wanted to learn about it. And it made me a better writer, honestly. Listen, Casey, basic level geology class. I went through this recently. Oh, nice. Very cool, Ike. Let me know if you've got any questions or you want to contribute. Yes, sand will break into a finer powder, especially depending on the conditions. But eventually, yes, it does disintegrate and break down. And what happens is, so if you get, let's say source to sink. I want to find a really good source to sink. Source to sink, geology. So if I can find a really good diagram, I can basically show you how various things are going to look. Let's see, the zones of a stream. This will work. Come on. Jesus Christ. This will work. We'll see if it'll look good. Nope. It's all right. It's all right. All right. So you've got your source, your mountains, and your sink, your depositional environment. But did you get a dual majors in religious studies and geo then? Yes, I did. I did a bachelor's of science in geology and a bachelor's of arts in religious studies, and then a master's in geology. Religious studies was actually very interesting, though. It really was. I got to learn a lot about what other people believed and how various religions evolved in scholarly ways over time. Like, that's the way in which I studied it. I looked at the literature and studied that. I looked at, it was predominantly literature, various textbooks describing various, for example, in Hinduism, there's, Buddhism, there's two different main branches, Mahayana and Theravada. Theravada being the more traditional and Mahayana being more ritualistic and burning of incense and things like that. So it was really, really interesting to me to go in depth with that kind of thing. I just wanted to learn about it. I didn't really do much on the Western side of things, except with, I actually did dive into Judaism quite a bit and Islam a little bit and read a bit of the Quran. My favorite religious texts, however, were the Upanishads and the Bhagavad Gita from Hinduism. They're interesting and very story-like, but have so much wisdom in them. And it doesn't matter if you're religious or not. They're just super wise texts. It's a lot of good shit in there, man. But no, I'm not religious. It was just it was a good time, and I have no regrets. Absolutely no regrets at all of doing that. Yes, it's not going to give me any jobs or anything, and I wouldn't do it solely. I did a dual major with a science degree, but no, I would not recommend anybody do a religious studies major on its own. I would really highly recommend that you do something that can maybe get you some kind of job or something. It's not really much. I just wanted to learn it. What math classes did you take up until Calc 2? St. Luke. We took up to Calc 2. And I actually really liked it. I just don't remember any of it, to be honest. I probably could teach myself the things again. I just don't really have any need to. Archaeology. No, I don't want to do that. Exactly. They're really interesting to learn about, even though you're an atheist. See? Literature side could be interesting. Exactly, Jen. See? Indoctrinated as a kid, so you're totally avoided that and got to college. Oh, really? Interesting. See, I wasn't indoctrinated as a kid, I guess. Like, I had family members and do have family members that are religious, but, and, you know, they do the whole thing like, oh, I'm praying for you and all that, and it's sweet of them, and I know they care. It's just not my thing. We got into talking about weathering and erosion and all God knows what. Geology good for potential employment? Fuck yes, it is. How willing are you to forgo your morals? And that's all I'm going to say, because I don't want to be blacklisted from certain industries. To be honest, there are a lot of opportunities. In geology. Some of those opportunities, however, involve working for oil. And those opportunities just aren't for me. But they pay a lot. You're afraid of calculus in your future? It's okay. You can always get tutors, and there's Khan Academy, and there's lots of educational streamers that probably can help you with that sort of stuff, to be honest. But Khan Academy is one of my favorites. I refer people to Khan Academy all the time, my students, when they're having trouble with any of the other side sciences that we use. Ominous. The irony of geology employment is that geology, you probably learn all kinds of things about global warming and fully understand it's a real thing, but then your best employment opportunities are from the petroleum industry. Yeah, exactly. That's exactly what I mean. It's, it's, yeah, I can't talk about it, sadly. You could teach for pennies, exactly. I chose the teach for pennies route. Connie's great, isn't it? You're doing a lot of Khan Academy lately. It is good. See, I came from a department drop air that was all petroleum, not any mining. I find that mining is more common out here, though. And to be quite honest with you, is the more sustainable of the two industries long term, like really, really long term, I would think, because it takes millions of years for petroleum products to be made naturally. And I don't know that we can do it. We can't do it. Otherwise, oil companies would be doing it if it was cheap and cost effective. But geology does have other opportunities as well. You could go into hydrogeology. You can go work for the government. You can work for environmental consulting companies to determine who can and can't do the things that they're doing in various industries. If they're doing things wrong, you've got to basically keep them in check. And things like that. There are quite a few opportunities. Seismic, you can go work for. God, there's all sorts of opportunities depending on the field you get into. And then academia, of course. Academia is always a big one. The USGS hires. I'm sure other countries have their geologic programs as well that you could probably find employment with as well. Physics was, I think, more interesting than the math and the calculus, to be honest. Oh, geology is such a vast curve. Fuck, I get that. Picking a topic is in geology is impossible. I know, space mining. In fact, Fraser Kane asked me about that, and I'm trying to come up with a decent recorded answer for him. Oh, I know, and I don't know much on paleontology, Rev. All right, all right. I do want to look at the sand, but I do want to explain to you guys that again, this is the source. So this is where things start to get weathered and eroded. Various processes can do this. You can get freeze thaw. You can get roots that grow into rocks. Just rain alone has a acidic pH naturally. Of course, snow. All sorts of wind erosion as well. And it gets windier the higher up on a mountain you go, if you've ever climbed one. And so you get a lot of strong erosion in these areas. And eventually it runs down streams, typically. And then and some of it can run through wind. And the smaller the particle that's eroded, the farther it can travel via wind and water. So if you're a clay-sized particle, you're going to end up at the bottom of the sea. If you're a big boulder, you're probably going to end up at the base of the mountain here. And it'll take a lot longer for that piece to erode away. The more surface area there is, the faster something's going to erode and weather. And eventually things get deposited through the rivers, and the smaller and smaller particles go farther and farther and farther. And this is the cool part. You get these interesting depositional features in the rock record. So, for example, in this area here, you get a really weird mix of things that would turn into what's called a conglomerate. So it would look like this, conglomerate. It also would have a certain sequence. As it deposits over millions and millions of years, it would look a specific way. Oh, fuck, I forgot. We were big mode. So a conglomerate would look something like that. Just a mix of crap. Small particles, big particles, all of the things. Oh, great. Shutterstock. Don't ever, please God, don't ever buy a picture of a conglomerate on Shutterstock. If you want a picture of a conglomerate, I will send you one. For good God. Jesus Christ. Please don't give them your money. It's ridiculous. Oh, here's an SEM picture of maybe not an SEM. Oh, that's cool. That's cut and sawed in half. You had to retake physics also? You couldn't grasp of it properly. It's very abstract, Fatal. Having a newborn didn't help. Yeah, I imagine that it didn't. I took it during my second calc. I took during field geology, which was a bad choice. So I'm gonna say taking it with my last chem, my last physics, while teaching myself physics for the physics-based calc that I was in. Oh, that was a bad choice too. Stats is easy. I really like it. I don't remember any of it because it's been a decade, but stats was great. Going back to the source to sink. Now this was the middle. All right, I'm not gonna blow the image up again. And as you go out now, let's say you get to a beach or coastal area, you're gonna get a sandstone. And sandstone. So you're gonna get something that might look like that, right? Once it becomes a rock, once it's buried and lithified. And then once you get to, so you go from conglomerate to sandstone, and then you get shale at the base of the ocean, the finest particles. It almost looks like basalt. And it's very, very obviously not basalt when you see it in the field, but that's, so somebody asked about the size of particles and how they become smaller and smaller. And yes, they do become smaller and smaller. And especially over time, the longer that they're in a system from source to sink, the smaller they're going to become. So that's what's happened. Those are the rocks that you get in those types of depositional environments, and that's why. That's basically the physics behind it. Pretty good shit. You love shale? Yeah. You have a shale flower vase? Really? That's cool. Shale can also be a lot of colors depending on the mud that's deposited. It can vary wildly. Wildly. Shreds tires, yeah. Rock slides, yeah, that makes sense. It's not a nice rock. So let's, I want to look at this black sand. This is going to be great. There's some glass here, I think, some volcanic glass. That's what it looks like. Let's put that to the side here. So this is from Miyojima. This is the black sand from Miyojima, and only 15 people are allowed to go there a year. We're going to look at it under a microscope camera if I can make this thing work. Polly! No, I have never been here. They allow 15 people from the military here a year. I just have some sand from Hania. I don't know how she has the sand. I forgot. But this is the black sand from Ioto. Am I saying that right? Then that's the new name, right? Apparently means sulfur island, right? Which makes sense as it's a volcanic island and there's probably some sulfuric gas.